We've talked about the scientific method as either conf- disconfirming or not disconfirming some hypothesis. What I want to talk about now is hypothesis testing. Some people, a lot of people, think that hypothesis testing is the scientific method. What's important is that hypothesis testing is one way of looking at hypotheses. It's not the only way, it's the most common way and the way that you're most likely to see. But all hypothesis testing is doing is looking at how likely or unlikely the results you got are based on the null hypothesis. So, even when some intervention has no impact, we expect to see some difference between the groups. So the group, if we have two groups of clients or subjects, one group gets an intervention, the other group doesn't, we would not expect them to come out exactly the same, even if there was no impact. So what we want to know is the difference between the groups when the study is done due entirely to just chance or time or random factors, or is it some sort of real effect from the intervention? Now, you can't prove a negative. So the purpose of the experiment is to give the data a chance to reject that null hypothesis. So it would take an infinite number of unsuccessful experiments to prove that some treatment has no effect. But we can reject the null hypothesis if we just get one study that shows that the intervention does have an effect. So back to our example with the green jelly beans. So if our research question is, do green jelly beans cause acne? A precise way of formulating our alternative hypothesis is, if we have two groups of people and one group gets green jelly beans and the other group doesn't, the number of people who develop acne in the group that eats green jelly beans will be greater than the number of people in the group that doesn't eat green jelly beans. Now, even if green jelly beans have no impact on acne, we'd expect over time some members of each group to develop acne, just because if you take two random groups of people, follow them over time, some of them are going to develop acne. So our null hypothesis is the number of people who develop acne in the group that eats green jelly beans will be the same or less than the group that doesn't eat green jelly beans. So at the end of the study, we will have two groups of people. One group ate green jelly beans, one group didn't. And we'll look at how many people in each group developed acne, and we'll do the hypothesis test. And what the hypothesis test measures is, if our null hypothesis is true, what's the probability of getting the results we got? And the way we measure that is with a p-value. So the p-value is the probability of getting the observed outcome we got purely by chance when the null hypothesis is true. So let's go back to those coin flips from the video. So if your alternative hypothesis is that a flipped coin is always going to come up heads, that would require an infinite number of coin flips to prove that it's true. If your null hypothesis would then be a flipped coin will sometimes come up tails. And your p-value is the probability of a coin coming up heads 78 times in a row. That's your observation, your outcome. if a flipped coin sometimes comes up tails. That's your null hypothesis. So it is theoretically possible to flip a fair coin 78 times and have it come up heads 78 times in a row. It's very small, but it's not zero. That's what your p-value is giving you.